I just realized this is basically the second last slide, so we could have just pushed through. I was so shocked that I was 15 minutes over. So when we look at version 14, we will see that the output looks slightly different than this, but we will the rank test will literally not change. It's just that when you estimate the model, there might be more deterministics at play. Okay, if you perform a rank test on those three variables and you get this result, it's literally all over the show. That one says no co-integration. That one says all three series are stationary, and anything and everything in between. So which of those results should we believe? So we already said we will throw this one out because it assumes a quadratic data trend, so explosive data. And we haven't seen that in our data when we look graphically at the results. This one we will not consider for now because it involves a trend in the long run. So the money demand equation does not have a trend in there driving money. Time does not drive money supply, money balance, or the demand for money. So that one is out, and this one we said is not very applicable because no data trend, no intercept, no trend, no nothing. So we will believe these results here, and we said the trace test will give us a more consistent result, but it's always good to look at the details, because in the detail we can see, so in this case I have selected option 2 because of that discrepancy. But we could have chosen that one as well and still put the rank at 1 and let that result override the maximum eigenvalue test. So, as I said, looking at the broader results, we can see in the margin at the 10% level, it does pick up, which will probably be an association, even if it's just statistical, between those two variables. But at the 5%, which is maybe a good, as the software suggests, that's the preferable level of significance to conduct this analysis with. And if we then do the final step, which is all in one, and actually I broke the result up, it will be one long screen. That result is shown down here. But then we know what we see in this first block. It actually tells us this is my co-integrating equation, except for the fact, can you see that the signs are the opposite? It's not that the signs are wrong, it's just that money has been taken to the same side of the equal sign. So you have to take money. Money is now that side with a parameter of 1. So if I take it to the left-hand side, it becomes -1. So I multiply through with -1. So then I get a positive and a negative and a negative. So this is what that column suggests. This is my long-run result.
Well, you are saying it's like the way we have the left-hand side, right-hand side. Mm-hmm. Everything on the right is on the left.
Yeah, everything, the null is on the left now. So, and then we standardize, so we bring this one to the, well, it is standardized, but it's standing as it is now. There's a 0, and this is then equal to 1 times this minus this times that. And then if I take that one to the left, it becomes -1. I multiply through by -1, and then so in simple terms, you just have to switch the sign of all the parameters.
Would that be the case for, like, if you run this again with different data, like, do we always interpret, like, from EVUs, do we always interpret the data as the results like that?
Yes, it will always be displayed like as, remember in the slides, that's why some of the co-integrating vectors were written alpha x1 plus beta plus alpha 1 x1 plus beta alpha 2 x2 with parameters not normalized. So then you normalize by making that coefficient 1, and then to make that the dependent variable, because at this stage it just happens because we have one co-integrating vector and we've selected that one first, it will have normalized on that one. But it still has it on, everything is on the right hand side, the 0 is here. So the money is that side with a parameter of 1, so we bring it this side, but then all the signs will switch by mathematically multiplying by -1. And if we look what's down here is the rest, those are the dynamic terms as we plug it in the error correction model. Here it will just happen automatically. And another thing is, remember we started out with a var of 2, but when we get to the ECM, you reduce that lag by 1. Because you estimate in differences, 2 lags in the levels will mean 1 lag in first differences.
No.
Lucius, now I see you.
Oh, yeah.
Your head is thinking at 700 miles per hour.
It's good. Okay, that part.
Yes, let's think about that a little bit. 2 lags in levels. So you have, for the first equation, you have y is a function of y minus 1, y minus 2, x minus 1, x minus 2. If we difference this is y1 minus yt minus yt minus 1. If you have 2 lags there, that equates to having yt minus 1, yt minus 2, and yt minus 2, minus t minus 3. Then you already have 3 lags in the whole story. So you reduce it so that you stick within 2 lags.
So on the software.
You will see, I will show where it will warn you.
Okay.
It will say in the levels var, the reduced form var, it will say number of lags in the var. And then you go 1 to 2. And then when you go to vec m, it will say number of lags in d, in the difference of, of the variable.
That's when we have to go down.
1, yes. If you don't do that, I don't think it's not the biggest train smash. It's just that then it would be as if you started with a var of 3. That's just the implication. The adjustment, speed of adjustment, this is the error correction. This is that alpha in front of the long run. So that speed of adjustment is like also slow to moderate, as we've seen before. And what we see here are standard errors and t-stats, no p-values. And these are then the... And now we cannot be so strict to say if we have something here that's not significant, we don't have a way of throwing it out. But if it doesn't matter, it doesn't matter.
Yet we should have reservations doing the same with the ECM. if there are an insignificant short-run dynamics in the ECM, you said we should be, we should not.
In the Engel-Granger method, we actually only include significant elements there. But sometimes you can also keep something that's marginally significant if it really matters. So say we want to add the effect of the global financial crisis to this model, we can still do it. I can add it in the long run, I can add it in the short run, I can add it in both. Or if it's about exchange rate and we know commodity prices matter, we can put the gold price in the short run of the exchange rate model. So let's do, I have this an updated version of this example that we can do together. If you go to, it's easier for me to show it on our drive, because I can make it a little bit bigger. We're now already busy with folder 9. By the end of Tuesday, you thought we will never see this 9. So in practical example here, the folder 3, you can just get it from where you've saved it in your file system. We will refer to this prac vec-m illustration, and there is a vec-m work file and a key vec-m key work file. So you can just open the key, otherwise you'll have to do everything manually, but it's fine, whatever. I suggest you open the key file there. So what you have then is, this is the work file, and this is the this one. So we will, and I know this is now maybe a little bit small, and I have no idea what I can do because we need quite a little bit of space here with the fonts large enough on the software. And that doesn't work. Maybe I could make this still a little bit smaller. Okay. So we will just start out by kind of replicating that. And if this is quite cluttered, you can do it on this side where there's not so many things. So for now, we just want to do this simple Keynesian money demand equation where real money is a function of real income and the nominal bond rate to measure that opportunity cost of holding money. And then I will show you one application where we implemented the Friedman, acknowledging that the world is more, there's more options than just putting your money in the bank or under the carpet or buy bonds. Those are too restrictive. And then the alternative, since we have a long rate here, the bond rate, I have a secondary equation that I said the bond rate will fluctuate or will be affected by the repo rate. Typically what policy rate is set, money market rates and capital market rates tend to move in tandem, maybe with a lag. And then also what the debt levels of government is will determine what the rate is. It may be through how much government can borrow or not. That debt levels will also affect the rate that they should charge to accommodate for risk and sentiment and so forth. So we have two equations here. An alternative would be to maybe have something like a Taylor rule, where we put interest rates as a function of the output gap and the deviation of inflation from the target. That would be another nice application in this setup, to try and model a Taylor rule as a secondary relationship going on here. So this is what we will do. But let's first just replicate it for, let's just use the three variables and go through the motions, just that you see it there on your own work file. Are you kind of with me? Or are you, let me rather, I don't know. Unless you have to attend to other urgent matters. So where do we start? Let's follow kind of what we have here on the left-hand side, thinking through, and at least then we don't have to do every single step that is already done here. If we have now, if in that two relationships, you can see you in any case start with kind of an economic model that you want to test. The variables that you selected is because you think you can tell a story with that 5 variables. I think money and a Taylor rule will probably be less. This is very intuitive, but interest rate outcome, capital market rate outcome is definitely a function of what happens from the monetary side, policy side, as well as from the fiscal side. So there are our variables. Clearly they are a mix, non-stationary, others we're not so sure. This may be a mean reverting process. And once again, look at this good run that we had early 2000s. Everything went in the right direction between early 2000 and the global financial crisis. And then we had that, and we had the regime change, and many things changed after that. With the limitations that we started seeing on our energy sector, which and of course other things as well. So the first step is, where do we start? We've generated the variables in logs, and then we want to investigate the money demand equation here, selecting. And now I didn't call it bond, I called it interest rate long. I think it's the 10-year bond rate, if I'm not mistaken. 10 years and over. So what do? I open that as a var. That's why we had to discuss var and then vec m. And we allow for, if it's annual data, 4 years, 6 years, so if we allow for 4 years, we will have a 3-variable var of order 4, so 4 lags of every variable. So you can see it's already a lot of parameters to estimate. Now we have to determine how many lags do we want to include in our analysis. So we do that by accessing the lag length criteria through the lag structure option here. And if we allow for 4, we have one way of thinking is what is the majority vote here versus, yeah. So if I see this, my go-to choice would most likely be 3 lags. I cannot really justify and use that argument that we don't want to over-parameterize, I don't want to overfit the model. 1 more lag can hardly do that. We want to opt for more lags than fewer lags. But for the moment, I'm going to ask you to let us do it with 2 lags, because it is written out here, and then I can show you at some point when I go through all the motions and I estimate the VEC M, there's not indication that the error correction mechanism will significantly bring the system back, and it's also quite low. So we should let the economics override that lag selection test. So let us then rather do it for 2 lags. Let me just see, this is everything. So we literally have to skip. So I went through the whole process and then left that and say, let me just see if I go with the criterion that we in any case feel is most of the times the right one. The Schwarz information criterion that has that trade-off, that balance of finding the best parsimonious model, not too many lags, not too few lags. So based on that, let us now estimate, but when we go through the whole process, you can just refer back to the VAR 3, but that one in the final step doesn't give me what I believe is useful. So what do I do now? Now I estimate still the standard VAR, the reduced form VAR, but with 1 space 2. And you can see lag intervals for endogenous. The VEC M will say lag intervals for difference endogenous. Yeah, so we're now still busy with step 1. So we go for 2 lags. We don't have any exogenous variables at this stage. We just estimate that VAR with 2 lags. Then, of course, we want to be sure that it's stable, the inverse roots are inside the circle. So if we go lag structure AR roots graph, we want to see that they are not outside the unit circle.
Prof,
Yes.
1 dot is...
Let's see if the table, it mustn't be bigger.
Oh, okay.
Yeah.
So we can work with that.
So we have that, so we can just estimate. And then just this is almost an optional step to try and understand how will the linkages, that transmission, how will it work? So we can see that this is the dependent, if this is the equation that we're interested in, and both of the explanatory variables are significant. In this case, money affects GDP, interest rates affect GDP, but not so much money doesn't affect interest rate and GDP doesn't affect interest rate. Perhaps with longer lags or something like that. But this is good news. This is how we expect economic theory and the market will work, the demand for money, balance there. Now is when we have to figure out, do we have co-integration and how many vectors? And you will now see that there are more options. It's not now just that small little table. And you know sometimes how you see people complain, especially if you for social media. Every now and then the people from Facebook or from Instagram they change things around, and then you see people write, why fix things that are not broken? Now it's not, I don't like it anymore. So they've given us much more now, maybe more than what we asked for, but so what we want to do is to go to co-integration test. And now you can see now it looks different than that little box that only gave us 5 options, and 1 and 5 we couldn't use, and 4 was very specific for a function with a trend in, so we looked at 2 and 3. It's pretty much the same thing. But now you can also, it also allows us here, although that was also always the case, that you could put in an exogenous variable. But now you have a choice here or both. And what I found is when I click the summary, which is supposed then to give me that small little table, I think in this case it complains. I don't know if there's maybe a little more. Oh, now it works. I don't know, maybe I tried it for a different application, because it then said not enough observations, and oh, I think it's for the exports example. And then you had to do it one by one. So at least, now they've added these wizards, so at least there's some descriptions there, so still, case 1 is no deterministic terms, and this is not what we after. So we still search within 2 or 3. Case 2 didn't change. Case 2 assumes the data have stochastic trends, and the co-integrating equation has a constant, and the short run has a constant. Case 3 now, based on other work, Johansson and his wife, Jucelius, or Soren and Katerina, they teamed up with David Henry. So Sweden and UK teamed up for this one. They split case 3 now in 2, where case 3b is short-run dynamics include a constant, whereas 3a is the one that used to be a constant in the short run and the long run. So according to me, it almost looks like case 3a is similar to case 2, except that it can accommodate data with a deterministic trend, where case 2 is only a stochastic trend. And then 4, we can ignore quite a bit, because all of this, there's a trend in the equation, and we don't have a trend in our money function this side. So, but nevertheless, That's what we deal with. What test result do we get? Just a little bit more information. This is what we had before. Now we have. I just want to allow for. Yeah, that's if you don't have a loose mouse but a trackpad. You're not so quick on the getting the. Let me just open it like this. You see, now it's more cases, but I think we can still circle case 2 and case 3. And this is what we had previously, that this aligns with that result in version 13. Exactly that. So we can still go for case 2, and we can let the trace test result override if we want to go with 3, so that's also possible. Although this and this has the same deterministic structures, just different underlying data assumptions. So this we can pretty much ignore. So what is the next step? To go to estimate. Now we don't want to estimate the standard var anymore. We're going to estimate our vec m. And if you go to co-integration, we're going to make sure that the rank is 1 there. And here we then want to go for option 2, the co-integrating constant. But I am pretty sure, I haven't tested, you can test it on the side, that option 3 will not give vastly different results. It's just because of that maximum eigen value test that says 2, I kind of refrain from that. And this is literally the result. Now for a different data set, that income elasticity of money is just a little bit higher. But can you see the minus should be interpreted as a plus, and the plus here should be interpreted as a minus. The interest rate elasticity is quite low. Oh, let me just, I've skipped one step. Let me just go back and estimate the var again. Oh, and I should have done this 1, 1. So let me just estimate this var and then view the co-integration test that we can see the details. Instead of only looking at the summary, look at the option 2, and then we can see the trace test and the so at the 1%, we have one co-integrating vector at the 5%. Based on both the trace test says 1 and the maximum eigenvalue test suggests 1. So exactly, so nothing changed here. Literally all they added was more deterministics in the co-integrating equation and or the short run. If we estimate the vec m, why that coefficient changed so much? It's because I forgot. When I estimate the vec m now, I make sure the rank is 1 by going to co-integration tab here, setting this to 2, but here I have to not click return, but change this to 1. And then we get those parameters that we...
Oh, yeah. Now basically it's significant.
Yeah. So let's see. Yeah, so the speed of adjustment is here. If you scroll down, everything is there. The thing is just when we did the Engel-Granger method, we were so busy with dummies. What happened to the dummies? There weren't that many dummies in the money demand. We had financial crisis in. So you can also, the model, you can still solve the model here with the representations, just like before, see the fit, see where we miss things. You can look at the residuals, do they look well behaved? Especially this one. It seems that there's a little bit of heteroskedasticity, not a whole lot. Here, exactly 80s, 90s. So yes, it is still possible to add, especially if we solve that and we see we miss the target, we can still add dummies. We have that option, especially if we now maybe go through the tests and we have autocorrelation test, we have a heteroskedasticity test, we can interpret the parameters, nothing changed. We just arrived at these results all in one step, but everything else are still at play. The residuals must still be free from zero correlation, heteroskedasticity. So we want to fail to reject the null of no zero correlation. You can see there's a little bit of heteroskedasticity, and those things I get if I view residual tests. They are my diagnostic tests for the VEC-M. Some of them even exactly the same. There's also a normality test that we can do. They are the residuals. So, and we can also do block exogeneity tests on the short run. But remember these are changes in changes. So we can see in the short run, the relationships, the causal relationships are quite weak. We don't see a lot of significance here in the short run. So quite similar to the Engel-Granger results. And also, if you now compare the var of 3 with the var of 2, you can also, this is almost confirmation that the better one is the var 2 model that aligns better with the Engel-Granger method. So what about dummies? How do I do that? If I did a breakpoint test, you can still estimate your long run in the beginning, do a breakpoint test, even do a, since this is only one equation, I can do an Engel-Granger integration test, or I can subject it to, maybe if you then don't find integration for the, let's do that, and maybe that is informative here. Let me just name the var so that I have not lost everything. So what if isn't this the case where when we opened it as a group and view the co-integration that the p-value was 0.12? No, it's not this one. There was one example for money that the p-value was outside the 10%. So imagine that is the case and you want to bring that in. What will we do here? How can I perform that? We simply plug that dummy variable in as an exogenous variable when we do the co-integration test. So maybe you find 0, 0, 0, 1, and when you add the dummy, then you see you have one co-integrating vector. That is a possibility. Just like we did with the Engel-Granger. And then when we estimate that, we add the dummy in the short run as an exogenous variable. If you add it in the long run, the previous previous version, you actually had to select it as part of your var to get it in here. So this is still perfectly fine. If we add it as a long run variable, now it can handle it correctly. But if we added it as part of the set of variables, it will lag it here, but here it will difference it. So it couldn't handle a dummy in the long run, but now it can. The software has been adjusted. So when you estimate that var, you can add an exogenous variable now here, only in the long run or only in the short run. Otherwise, we had to add it up here, and that will be difference then. That was the only way. There was only one block for exogenous variables, and then it would have gone into the short run, like here. Now, you can ask for it. The only way to get it in the long run is to select it as part of to put it in that block. But then this would happen. And that would actually be, see what happens if we difference this dummy. If we difference, what is the difference of the financial crisis dummy? This will be 1 minus 0 is 1, but this will be 1 minus 1 is 0, and this will be 0 minus 1 is minus 1. So now you don't control the way you think you would. This is now not doing the right thing. It's a different animal, this one.
Can you have minus 1 for a dummy?
No, but if you difference it, you can. You can, if you did this, if you difference that dummy, that will give you the 1, this will give you the 0, and this will give you the minus 1. Yeah, that's a giraffe with leopard spots. I don't know. But we, it's easy not to realize what you're doing here. You will see how significant it is. But it's not, yeah. So now is the interesting case. I mean, that was straightforward. But what if we have 5 variables? That's when we have to know a little bit better our economic theory or whatever. So let's just look at that case. If we select now we want to select all 5 variables. This is where we will have to impose restrictions. So we select again money, GDP, bond rate, but now also the repo and the debt, the log of the debt. Those 5 variables. So this can be production and variables explaining the labor market, something like that. So if I open this as a var, And again, I can work with 4 lags, and then test the order of the var by going to the lag length criteria, allowing for 4, and now all the model selection criteria are consistent for 2 lags. So I estimate the var with 2 lags, and then I just want to be sure that I have a stable, I mean, that we can do. We can look at the, maybe first do the co-integration test like here, and now it will be again a big table. If we go to co-integration test, and then we want to do this for 2 lags, and if we look at the summary, you see that this, yeah, I got the insufficient number of observations. So what I need to do is to actually do it one by one. I think one of those, probably the last one, is eating up the... So if we, instead of a summary, just test for, stay within 2 and 3 and just look at those one by one. So because we believe 2 or 3 will work for us. And here we see it tells us 2 co-integrating vectors and no co-integrating vectors, but indeed 2 at the 10%. So we will, since we also know a little bit theoretically what we're busy with, we will opt for 2 co-integrating vectors. Is that fine with you? 2. Even though this one says no, it's 2 at 10%. But we will take the trace as the more consistent result.
We can come back to where we got a problem with the number of
Okay, let's go there. View co-integration test and select the summary. This is where I get an error. Do you also get this? Okay. Otherwise, that will be spooky.
For me, I'm still on us choosing 2 when integrating.
Do you have a problem with that?
Oh, no, I need more help getting the logic.
It is because I've selected all of these variables. I know that is the money equation. But if I also normalize on the long rate, this is just an example. I was thinking what else can be going on with a money equation. So I thought if I normalize on interest rates, perhaps that capital market rate, the outcome of the capital market rate is a function of what happens with repo, right? Where did I put that? Just my thinking. The first one is the standard money demand. So that one is just So I was thinking, what can I use to demonstrate that there's a second equation? So if I add repo and debt, and I make that interest rate a function of, if I endogenize that, and I said, well, what the monetary authorities do, if they up the repo rate, there's some interest rates tend to move like in a band. First, it affects the money market rates more, and later on the capital market rates. And also, what happens on the fiscal side? What happens if our debt to GDP ratio blows up? That's not a good sign. Rating agencies don't like that. They will downgrade us. We'll have to, that will increase the rate we have to pay to sell our bonds to buyers, investors. So this will be positive, this will be positive. It's not the best example, but it's also not the worst. Later on, I thought maybe a Taylor rule is what we actually see in papers. Yeah. So they are, and I haven't made it available with this course material, but there are a couple of papers that try to model the wage bargaining process. Harold, that's for you, for your labor. If you can model South African wage bargaining, but that's just so complex for South Africa. Not having great labor data, but also, our labor unions are not necessarily in the first place historically there to negotiate wages. It was also a vehicle for rights of workers and so many other things that it becomes difficult to model that. But there are models like that for Germany and the UK. So are you a little bit more comfortable now, Lucius? 100%. 100% comfortable. 80%.
But I am okay now.
Yeah. So it's not. It's merely to try and get another equation that we can, so that we have two co-integrating vectors.
Yeah, I think it goes back to what we indicated in the first place. You need a lot of theory
Yes.
to be able to
Yes.
make this.
Yeah. So if you publish that paper, you can give it to me to use as an example. Challenge accepted. So now we throw 5 variables at the test, all 5 of them, and then the trace test in the 2 models that we interested in, say 2. But you see now they fixed something that wasn't broken, and now it's broken.
Like as a rule of thumb, can we say the number 2 corresponds to where we fail to reject the null hypothesis?
No.
This test.
No. Why? Let's think. Why not? Not a rule of thumb. Maybe there could have even be a third thing going on there. Still the money and income. So you have to really, based on the economics that you put there. There's all the variables for a production function, and then there's a function for employment, and maybe wages.
Makes sense.
So if I don't do the summary but do I will then test 2, 3A and 3B and see what it tells me. But that I've tested and I get exactly these results. So I will still try and go ahead with 2 then. But now is where your economic knowledge comes into play, because now you have to place the right restrictions. Because remember when we had those big equation in matrix notation, there were like alphas here, alpha matrices, and then the betas. But since the rank is 2, we just keep 2 columns for the alpha and 2 columns and 2 rows for the betas. And here we now have to say, firstly, we're going to normalize on the 2 dependent. So where will we put the 1? This one is the parameter in front of money. So we will make it 1 there. Yeah, 1. Secondly, we want to make interest rates, normalize on interest rates in the second equation. So this will be 1, 2, 3 in the second row. That one we will make 1. And then what we want to say, we don't want repo or debt in the first equation, so we make these 0. There we make it 0. And then we don't want money and GDP in the second equation, so we make those 0. And that's our restrictions. To communicate that, we will simply say B11 is 1, B14 is 0, first row, fourth column, B15 is 0, and then B2, 0, B21 and B22, 0, 0, and B23, 1. And if you make a mistake, you will see it. So let's just estimate that var. If we go to vector error correction, we will estimate it now. The rank will be 2. The deterministics will be according to option 2. And I forgot to lower the, so it will go ahead now, but let me just go back and lower this to 1. And I can still add dynamics, exogenous components here. So this is now, yeah, you can see it kind of try to help us, but it will just normalize on the first one and the second one. So this is really garbage in, garbage out still. Well, not garbage in, but garbage out. So where do we place the restrictions? So we go back to estimate. We go, and there's a tab for restrictions, vector error correction restrictions, and it's exactly here if you indicate that you want to place restrictions. And I will try and copy this in. I don't know if it will work. I can just grab it here, put it on the clipboard, paste it in here, and let's see. Do we get what we want? Here is the first equation, the money equation, and where's the heading? They've changed it a little bit now. giving us more information than we need. They show us the restrictions. Oh, we can see it here. Here we have normalized on money. Here we have normalized on interest rates. Here we see repo and debt is not in the first equation. And money and GDP is not in the second equation. So if we write that result out, there are the two equations. So what we hope then is that this would make sense. And both of those parameters are positive. So on average, 1 percentage point increase in the repo will translate to a 0.6% percentage point increase in the capital market rate, and that's the impact of debt on that. So we can judge if that makes economic sense, but this is very similar to what we had before. So even robust to the inclusion of the second equation in the system. And then still see no zero correlation, no Yetruski elasticity. End of story. I guess you can still do normality, block exogeneity.
Now, since there are two equations, the result that we see on diagnostics apply to
Yes.
both.
Yes. So I would say, let me show you the one paper that applied that. This was the student of mine when he was honors in, I don't know which year, but he's now long gone. He's already had done his doctor's degree. He did his PhD at Stellenbosch, also in competition policy, and is now in the labor market. But we took that "Where's All the Money Gone" paper as a base, because for honors research you don't really have to reinvent the wheel. So we went a little bit beyond the money, the Keynesian money demand. This is just money growth and inflation rate. What that other paper was, what happened here with the velocity? Why did we see this decline around this period and now it's going up again? So Hall and a Greek co-author, it's probably in the reference list of this one, they argued that the money demand equation was misspecified. It didn't include wealth. So they included household wealth yeah, and then also modeled beyond the bond rate, also goods markets, inflation, in other words, and stock market over and above the bond market. And then applying that at least we only got one co-integrating vector, and that was then the report is there's the co-integration test, only one at the 5% level, and here's the result. So long run variables can be more than one, adjustment. Here's the slow adjustment and the short run dynamics there. But I think if you read papers, you will see many more papers using the ARDL. Now we're half an hour late for coffee. Is it? Not. Just on time. So shall we break for half an hour and then do the ARDL? But I don't have notes. I don't have slides.
Oh, you just talk about it.
No, I have a practical application. That the part that you're interested in. You're like, yay, no slides.
Fine.